Hi students, welcome to this video segment. My name is Samuel Chukwu Emeka. In this video session we shall discuss the second part of the video in the series, Plane Geometry Angles Part 2. And in this session we shall specifically look at the angle properties of parallel lines cut by a traversal. Please, before you begin this video session, it is highly recommended that you view the video on plane geometry angles part 1, and that you viewed videos on line segment, and the rest of them. Okay, it's highly recommended that you do that before you begin this video. Okay. Now, there are some interesting properties of angles between parallel lines that is cut by a traversal. Okay, as we've discussed in other video sessions, we know that parallel lines are lines that can never meet. Right? Recall, we see that parallel lines are lines that cannot meet. No matter how far they are stretched. No matter how far they are stretched. So they can never meet or intersect. No matter the direction it goes, they can never meet. Okay, so when you have this line, going this way, probably line AB, and you have another line this way, line CD. So no matter how, if you keep on moving this line, if you keep moving it, it's not ever gonna meet. If you keep moving it, it's not gonna meet. No. So these are parallel lines. Okay, now, since parallel lines do not meet, since they don't meet, that means the angle formed between parallel lines is 0. Okay? That means since they cannot meet, the angles formed between parallel lines, is 0. The angles between, just write the angles between parallel lines is 0. Because no angle is formed anyway, is 0. That means no angle is formed. No angle is formed. Okay. And of course, you know how parallel lines are denoted. Okay, you know how parallel lines are denoted. Like, if I have two lines now, let's say I have these two lines, line AB, and line CD, Okay, if we want to tell people that these two lines are parallel, there are two things we can do. We can either write it in the instruction that line AB is parallel to line CD, or another way we can do it is if we put an arrow here. If we put an arrow here, this tells you that line AB, I put an arrow here and I put the same arrow here. So automatically, even if you see this kind of lines, even if you are not told that the two lines are parallel, then just know that they are parallel. Once you see this arrow, you can also see them as double arrows like this. Okay? You can also see them as triple arrows. Okay, that automatically tells you that AB is parallel to CD. Now, if you don't see these arrows, and you are not told in the question that the two lines are parallel. Please and please, no matter how they look, do not assume that they are parallel. They are not. So for the instruction will say that these two lines are parallel. The instruction will say that line AB is parallel to line CD. This means parallel. These two things you see means parallel. Parallel. So this means line AB is parallel to line CD. They are going to tell you this, or they might say it in English, okay? They might say it in words that line AB is parallel to line CD. Or, assuming they don't say this or write this, assuming they don't write this or they don't tell you, but they put arrow. If they put arrows here, then that tells you that line AB is parallel to line CD. Take note of that. That is the way we denote parallel lines, okay? You must see it by an arrow, or you will be told from the question. Okay, so since these two lines will never meet, that means there is no angle that is formed. Remember, an angle is formed when two lines meet or intersect. We discussed that in the other video. Okay, now but there is something interesting here. There's something interesting here. If you have a line, another line, that cuts these two lines. Let's say we have a line that cuts these two lines. Okay? Assuming we have a line that cuts these two lines. Right? So, because this line has met another line, then this angle, an angle is formed here. We have this angle is formed here. Let me say alpha, beta, theta, pi. So already 4 angles are formed here. And here also 4 angles are formed. Gamma, rho, epsilon, lambda. So 4 angles are formed here as well, as you can see. So we want to study the properties of these angles that are formed by a traversal cutting a parallel line, cutting two parallel lines. That is what we want to learn in this video session. We want to know what are the properties of the angles formed when this traversal cuts the parallel lines. Yeah, because we have some interesting properties that are formed. Interesting properties of angles that are formed. So let's go ahead and get this started. Now, what is a traversal? A traversal is just a line. A traversal is a line that cuts, you can say cuts or meets, that cuts two or more lines. So, you have a line that cuts two or more lines, we have it as a traversal. Now, in this case, we are only concerned about parallel lines, please. In this case, in this video, we are concerned mainly about parallel lines. Okay, now let's look at the properties of the angles that are formed. Consider this parallel line. If you consider this parallel, consider a parallel lines below. Parallel lines below cut by a traversal. Cut by a traversal. So let's start with the simple ones that are familiar to you. So we have line AB. Line AB. And then we have line CD. And then this traversal cuts it. This traversal cuts it. Okay? Now, let's note here that line AB is parallel to line CD. Okay, so some interesting properties of angles are formed here. Some interesting properties of angles are formed here. One, I'm kind of going to, because I don't have space on the board. So the first property here we look at is the corresponding angles are equal. Corresponding angles are equal. That's the corresponding property. And in the short form, I'll just write it like this. In the short form, I'll write it like so. In this video, if you see me write CO double arrow and a period, and I write angles, that's what I mean. Corresponding angles are equal. Now, what are corresponding angles? Okay, from what I was taught, corresponding angles, you can easily identify them as Y angles. And I'm going to show you. Now, there are a pair of angles. We have one interior and one exterior. Now, you will now ask me what are interior angles and what are exterior angles. Okay, that's a good question. So I'll kind of talk about it now. So let's have this. Let's go back to this. Assuming we have alpha, beta, and I'm sorry, I'm going to use Greek letters again. Alpha, beta, theta, pi, phi, lambda, gamma, phi, lambda, gamma, epsilon. Okay. What we call the interior angles. The interior angles here, interior angles are, this is what I mean by angles. This is what I mean by angles. Interior angles are inside, they are inside angles. And that is alpha, pi, phi, and lambda. These are what we call 4 interior angles. They are inside the parallel lines. Okay, the exterior angles are beta, theta, epsilon, and gamma. Beta, theta, epsilon, and gamma. I hope the Greeks will recognize me for using their alphabets this time. I'm planning to go to Greece one day anyway. Yeah. But don't be mad at me, okay? Americans, don't be mad at me that I'm using Greek alphabets. Or Nigerians, don't be mad at me that I'm using Greek alphabets. Yeah. I love Greek alphabets anyway. But let's just use it for angles, you know. A lot of Greek scientists made significant contributions to the study of the earth, planetary sciences, geometry. A lot of them made significant contributions, even with the trigonometry. So we can just, you know. But I hope you understood what I'm doing now. Okay. So these are the interior angles, these are exterior angles. Now let's move back to corresponding angles. How do you recognize corresponding angles? Corresponding angles, we recognize them as Y angles. Okay, and look at what I mean by Y angles. Let me say, also known as Y angles, or can be recognized as Y angles. See what I mean now? Y angles. Y angles. Now, look at what I mean. With corresponding angles, when you have the traversal, you have this line, you have this line, you have an exterior angle equal to an interior angle. You see, if you can see something like Y, look at this parallel line cut by the traversal. So you see something like Y here. Look, I wish I had if I had a different chalk, I will show it, I mean it will be better. But look, something like Y, this and this. You see, something like Y. You see that? From the parallel line. And then you look at another Y again. So you have like, let's say, call this 2Y, Y up and Y down. But the main thing here with corresponding angle is that you have an exterior angle being equal to an interior angle. You see that? You have an exterior angle beta being equal to phi, an interior angle. On the same traversal, on the same, now with corresponding angles, it must be on the same traversal. Must. It must be on the same traversal. But it's going to be a pair of angles, an exterior angle being equal to an interior angle. And it should face the same way. What do I mean by face the same way? Look at what I mean. Look at what I mean here. It must face the same way. So if you have this now, for instance, you have this traversal, you have this, you have this. So you have this is facing like this. You see that? That is facing that way. And then you have this to also face this. You see? So you have this is facing like this. It must face the same way. And then this will face like this. That means they're corresponding. And then if you look at it also from here, this will face like this. You see? That will face like that. And then this will face like this. So they must face the same direction. Okay? So corresponding angles are also known as y angles. You can write it down. Also known as y angles. Then these are the properties. You have two pairs of angles, one exterior, one interior, that must face the same way. They must face the same way. This will face this. This will face this. This here will face this here. And then this here will face this here. Okay? That way it goes. So, just write it down. So, not to make this video so long for me to write it. Okay? They recognize as y angles. They are on the same side of the traversal, not on opposite. They are on the same side of the traversal. Then it is usually one exterior and one interior, and they must face the same direction. They must face the same way. Okay, so let's identify the corresponding angles in this. Let's identify the corresponding angles here. So what is it going to be? You see that beta is facing the same way as phi. So beta is equal to phi. Okay, then you see another interior angle alpha and an exterior angle epsilon. You see they are facing the same way, alpha and epsilon. You see what I'm talking about? They're facing the same way, and they are on the same side of the traversal. So alpha is equal to epsilon. And then you see theta. Theta is the exterior angle here, and then lambda is the interior angle here, and they are facing the same way. Okay? So theta is equal to lambda. And then you see pi, interior angle here, and then gamma, exterior angle here, and they're facing the same way. So pi is equal to gamma. Corresponding, they are corresponding. So please take note of that, it's very important. Okay? Now the next one, number two is the alternate interior angles. Alternate interior angles are equal. Now how do I write mine? I will just write it like this: alternate interior angles. You see how I wrote it? ALT period, then space INT period, angles. Alternate interior angles are equal. Because whatever I write, I'm supposed to give reason. When I teach students geometry, I expect them to give reason for every single thing they write. For every theorem, corollary, anything they write, any statement they write, they should give reasons. Whether it's triangle theorems, circle theorems, quadrilateral theorems, okay, or parallelogram theorems, they have to give reasons. So now, that's geometry. Now, when we talk about alternate interior angles, we are talking of interior angles, not exterior angles now. So we are looking at interior angles. Now these interior angles lie on the opposite side of the traversal. They can be recognized as Z. They can be recognized as Z angles. Z angles. Z angles. So look at the way I mean by Z. Alternate interior. That this here will be equal to this here. So you see the traversal. If you extend this line and you extend this line and you extend the traversal, you see that there is a Z that looks like this. It's like Z. So you look at the interior angles, they are alternate and they are interior. Okay? They are on the opposite sides of the traversal. This one is on this side and this one is on this side of the traversal. Recognized as Z angles. So pairs of interior angles on the opposite sides of the traversal are called alternate interior angles. And they can be recognized as Z angles. Z angles. Okay, so if you look at this parallel line, you try and find Z here. So we see that Z is here. Now how many Z's do we see here? We see two Z's actually. Because you see the first Z like this, and you see the other Z like this. Yeah, you can also call this as Z. Like this. Okay, you can also call that Z. Look at what I mean here. I wish I could begin to solve this so I will have space. Now, look at what I mean here. In this, you can see this like this. And you can also see the Z like this. I know you might say that this is not Z. But here, please call this Z. Backwards Z, call it backwards Z. Okay? You can call it backwards Z. So in this case here, when we have this and this is the traversal, we see that this one is equal to this. Yeah. Alternate interior angles. So we have two cases actually. This interior angle equal to this interior angle, and that interior angle equal to that interior angle. Two cases here with the alternate interior angles. It's very important you know it. Okay? So let's you can call this backwards Z. Okay? So let's find the alternate angles here, alternate interior angles here. So this means that if we want to use this property, this means that alpha is equal to lambda, and then pi is equal to phi. That is it. Alternate interior angles are equal. Alternate interior angles are equal. Alternate interior angles are equal. Okay, the third property, so that we can begin to solve questions, please. We need to get it started. The third property is what we call the vertical angles. Vertical angles. And I'll just write it like this, vertical. Vertical, V-E-R-T, period, angles. Vertical angles are equal. Vertical angles are equal. And in short form, I'll write the vertical angles as this. V-E-R-T, then angles. Vertical angles are equal. Now, what are vertical angles? Vertical angles are just opposite angles. They are opposite angles. They can be recognized as X angles. X angles. So how many X do you see here? You see 2X, you see? Now, the X angle I mean is that you have a parallel line and a traversal. Now that this angle is equal to this angle here, and then this angle is equal to this angle here. You see, in this case, I used a single line here, single curved line, and here double curved line. Yeah, that tells you that this is equal to this, and this tells you that this is equal to this. The double curved lines are equal to each other. The single curved lines are equal to each other. So that is x angles. So here, if you have this traversal, you have the traversal here, you have the parallel line here, and you have the traversal here. So you have the x like this, and then you have another parallel line here, and you have the traversal here. You have the x like this. So two x's. Okay? This. Okay? So let's recognize the vertical angles that are here, and then we can solve some problems. So in this case, here at this point of intersection, and you see the vertical angles always come at the point of intersection. I want you to know that. The vertical angles always come at the point of intersection. So at this point of intersection between the traversal and the parallel line and line AB, the traversal cuts line AB and line CD. So at the point of intersection of the traversal and line AB, we have vertical angles. Then at the point of intersection of the traversal and line CD, we also have vertical angles. So for that of the intersection between the traversal and line AB, we have that beta is equal to pi, and then alpha is equal to theta. The reason, vertical angles. And then at the point of intersection between the traversal and line CD, we have that phi is equal to gamma, and that epsilon is equal to lambda. Okay? Take note of that. Vertical angles or x angles. So when you talk of angles formed between parallel lines cut by a traversal, think of x, y, z. X, y, z. X being that the vertical angles are equal, y being that the corresponding angles are equal, then z being that the alternate interior angles are equal. Think about it that way, and you will not have problems. Now, there are so many other theorems with angles, okay, but for this session, it is allowed. Geometry is allowed, trust me. But for this video, we are just concerned about these three properties. Okay? Alright. I can erase this, and let's do another example. What if you have these now, two parallel lines? Let's say you have two parallel lines. What if you have something like this, two parallel lines? Okay? So, alpha, beta, sigma, kappa, pi, omega, rho, lambda, epsilon, phi, psi. You know, we have psi function. Psi, pi, gamma, lambda. Okay, I've put lambda. Gamma. What other functions can we get? Mu, zeta, Rho, have I put rho? Yeah. Lambda, beta, sigma, theta, delta. Okay, let's look at all this now. I want us to find the angle properties of these parallel lines. That's what I want us to find. You have two parallel lines now that cross each other. Let's say AB is parallel to CD, and this is CD. AB is parallel to CD, and EF is parallel to GH. So you have it like this. Line AB is parallel to line CD, and then line EF is parallel to line GH. Okay, how are you going to do this? How are you going to do this? So let's look at this now. And you know, I would have loved to actually write this out, but I just want you to let's do it. Probably I have to write it here. Corresponding angles. Let's look at all the corresponding angles. Corresponding angles are equal. Corresponding angles are equal. Okay. Alpha, you see, alpha and pi. Because look at the way, look. It is on the same traversal. This is on the same traversal. I'm not on the same, yeah. Call it, we're on the same line in this case. There's no traversal. Well, there's a traversal. Traversal is EF, GH. If you're looking at it this way, or you can look at it, if you're looking at, well, if your parallel lines are AB and CD as your point of reference, the traversal will be EF, lines EF and lines GH. But if your parallel lines are lines EF and lines GH as your point of reference, then your traversal will be lines AB and lines CD. So if you look at that, AB to be your traversal, you see alpha is corresponding to pi. They are the same traversal. So alpha is equal to pi. Okay? Then kappa is equal to omega. Kappa is equal to omega. Then beta is equal to rho. Beta is equal to rho. Then sigma is equal to lambda. Sigma is equal to lambda. Then epsilon is equal to mu. Epsilon is equal to mu. Then phi is equal to zeta. Then psi is equal to theta. Psi is equal to theta. Gamma is equal to delta. Gamma is equal to delta. Okay. Then it's not finished now. You now consider AB parallel to CD as your point of reference. So your traversals will be EF, lines EF and lines GH. So alpha is equal to epsilon. Your alpha is equal to epsilon. Your beta is equal to psi. Okay. Your kappa is equal to phi. Right? Your kappa is equal to phi. Then your sigma is equal to gamma. Sigma is equal to gamma. Then your pi is equal to mu. Okay, let's keep on with corresponding angles. I'm writing it here. Your pi is equal to mu. Your rho is equal to theta. Okay, look at the way they are. Your rho is equal to theta. Your omega is equal to zeta. And your lambda is equal to delta. Your lambda is equal to delta. So these are all the corresponding angles you have. Yeah. When you have two parallel lines acting as traversals, when you have two pairs of parallel lines, you know, when one pair is acting as a traversal to the other pair, you have a lot. You have a lot there. Okay? Now let's look at alternate angles. So these are not the corresponding angles. Now let's look at alternate angles. Alternate angles are equal. Now this question is for this. Okay? This question is for this. So alternate angles are equal. Alternate angles are equal. We have that now alternate interior angles. Alternate interior angles. Alternate interior angles are equal. So here we have that z angles. Let's find the z. Okay, beta is equal to phi. Beta is equal to phi. Sigma is equal to epsilon. Sigma is equal to epsilon in this case. Then here, rho is equal to zeta. And then lambda is equal to mu. Lambda is equal to mu. Okay? Okay, that is now if we take the point of reference as lines AB and lines CD. What if we take the point of reference as lines EF and lines GH? So we look at it this way. Okay, we better look at it this way. Right? When we take this like this, we have to look at it this way. So if we take lines EF and lines GH as the point of reference, and then lines AB and lines CD as the traversal, what do we have now? So we have that beta is equal to phi. The same thing, we just have the same thing, okay? Epsilon is equal to sigma. Mu is equal to lambda, and zeta is equal to rho. Okay? We have the same thing if we do it that way. Because they're all the interior angles. Remember, the interior angles are zeta, mu, phi, epsilon, beta, sigma, rho, gamma. Those are the interior angles. Alright, now let's go ahead and do vertical angles. Let's do vertical angles. Vertical angles are equal. So what do we have as the vertical angles? Alpha is equal to sigma, right? Beta is equal to kappa. Epsilon is equal to gamma. Psi is equal to phi. Psi is equal to phi. Pi is equal to lambda. Rho is equal to omega. Mu is equal to delta. Theta is equal to zeta. Okay. That is it. Alright? So please take note of it, and no matter how they draw, now these folks can draw the lines anyhow they want. Okay? But your thing is to make sure that you can comprehend it very well. That's the main thing. Okay? So I hope you understood it. Don't worry, when I'm solving these problems now, I will now use English alphabets. How about it? Or should I use Nigerian alphabets? Igbo alphabets? No, because you won't understand what I'm saying. You will all get mad if I do it. Okay, let me erase this so that we can solve these questions and call it a day or night or anything. Okay, let's do the questions here. So when I find the angles here, question 1 and question 2. When I find all these angles, all of it. So assuming I call this A, let me call this A, B, C, D, E, F, G, H, I, J, K, L, M, N. Now O you might think is 0, so let me use P. P, Q. I'm running out of this. Okay, P, Q. Now let me call this R. Let me call this one S. Let me call this U, V, W, X, Y, Z, and here, what do I call this now? Should I use any Spanish alphabet? Let me just put this alpha and then beta. How about it? I wish I could use Igbo alphabets, but but I just mentioned this so Igbos will know that I recognize them, okay? I appreciate them. Alright, now let's do this stuff right away. Okay? Okay, so let's find all those angles. Let's find them. It's a lot of them. Let's find them with reasons now. With reasons. Okay, so now we know that AB, this is now a line segment. Line segment AB is parallel to line segment CD. Okay? Line segment AB is parallel to line segment CD. And the line segment EF is parallel to line segment GH. Okay? Alright, so angle B is 85 degrees. Reason, vertical angles are equal. Small b. Okay? And then A, small a plus 85. A plus 85 degrees is equal to 180 degrees. Reason, angles on a straight line. Angles on a straight line. We talked about it in the first video. So that means that A will be 180 minus 85, which is what? 10 minus 5 is 5. 17 minus 8 is 9. 95 degrees. Okay? A is 95 degrees, right? Are you with me? Are you with me? So C is also what? 95 degrees. Reason, vertical angles are equal. Vertical angles. Vertical angles are equal. Okay? Or we can just say vertical angles. Then A is equal to D. A is equal to D equal to 95 degrees. Reason, corresponding angles. Then B is equal to F. B is equal to F equal to 85 degrees. Reason, corresponding angles. Corresponding angles. E is equal to 85 degrees. Reason, corresponding angles. Okay. Then C is equal to G equal to 95 degrees. And that is still corresponding angles. Corresponding angles. Remember what I taught you? It should correspond and it should be on the same. It should be on the same line and it should follow the same direction. D, A, B, F, C, G. Okay, we have finished this traversal. We finished it. And of course, F is 85 as well. You can also say that F is 85, reason alternate interior angles, and then C is equal to D, which is 95 as well. We can also say that F is 85 degrees. F is 85 degrees, reason alternate interior angles are equal, and then C is equal to D equal to 95 degrees, reason alternate interior angles. Okay, now let's look at this. D is equal to M also. D is equal to M equal to 95 degrees. Okay, that's corresponding angles, because look at it now, the same traversal. You see this and this. D is equal to M, right? Then E is equal to N. E is equal to N equal to 85 degrees, reason corresponding angles. Then G is equal to Q, because look, G and Q. G is equal to Q. G equal to Q equal to 95 degrees, reason corresponding angles. And then D is equal to M. Okay, F is equal to P. F corresponding equal to P. F is equal to P equal to 85 degrees, reason corresponding angles. You can also say that M is equal to Q, vertical angles. Then P is equal to N, vertical angles. You can also say that. Then we have that I is equal to P. Do you see the Z? Do you see the alternate interior angles? You see something that looks like Z. You see? Where you can find Z angles. I is equal to P. I is equal to P equal to 85 degrees. Alternate interior angles. Parallel to GH. EF is parallel to GH. H plus 22. You have to be careful. You really have to be careful here. Okay, so I is equal to P equal to 85 degrees. Alternate interior angles, right? All right. Now, you have to be careful here. We see that EF, line segment EF is parallel to line segment GH. So, you look at this, H plus 22. This entirely will give us 180 degrees, right? But H plus 22, because this lies on the GH. So, H plus 22 is corresponding to M. Do you understand what I'm saying? H plus 22 is corresponding to M. Because look at it now, this line. Now you see there's another line here that cuts this. Don't allow that line to confuse you at all. Okay? Don't allow the line to confuse you at all. So, this here, H plus 22, H plus 22 is corresponding to what? M. Okay? So don't allow this line here to confuse you. So we see that M is equal to H plus 22. And that is 95 degrees, right? Reason, corresponding angles, So H will be 95 minus 22, which is what? 5 minus 2 is 3, 9 minus 2 is 7, 73 degrees. So H is 73 degrees. This is 73 degrees. H is 73 degrees. Okay? Corresponding to N. And we found N, yeah, E and N. Okay. Alright. Now, and we found Q as well. Okay. We found P. Okay. Now, let's find L. Let's find L now. So you see that this whole is 95. 95 plus this should give us 180. So we can find L. Okay? Yeah. Just be careful how this goes. Let's go ahead and finish this up. So our 73 plus 22 plus L should give us 180 degrees. And the reason, angles on a straight line. Okay, so L is 180 minus 73 minus 22. L is 180 minus 95. Okay, so L will be what? 85 degrees. Right? So L is 85 degrees. This is 85 degrees. Okay, now we see that this is also what? A straight line here. L plus K plus J. L plus K plus what? J. Right? Now, but before we do that, we don't know what J is. So what is J? J, we see that there's 22 here, right? So J is 22. Look at it. It is still vertical angles. Now, I know that it is not between parallel lines, but vertical angles applies to even lines that are not between parallel lines. I mean, vertical angles applies to even angles that are not between parallel lines. So J is 22 degrees. Vertical angles. Okay. So now L plus K plus J is on the same straight line. And the straight line is GH. The straight line is GH. So L plus K plus J is 180 degrees. L plus K plus J is 180 degrees. Reason, angles on a straight line. So this means that 85, L is 85 plus K plus 22 is 180 degrees. So this is K plus 107 is 180 degrees. So K is what? K is 180 minus 107. 10 minus 7 is 3. And 7 minus 0 is 7. 73 degrees. Okay? So K is 73 degrees. K is 73 degrees. Okay? Now, we found this, right? Okay, now let's come back to this. R plus S is 104, so let's find what R is. And after finding what R is, we can find what U is. Okay? We can find what U is because this is a straight line. Okay? And then we can find what S is. And then R and beta is corresponding as well. Is vertical as well. U and W are vertical. Okay? So R plus S is 104 degrees. R plus S is 104 degrees as shown. Now let's find U. U, what is U? Because this all together, this is on the same straight line. Okay? Now 104 plus U will give you 180 degrees. Reason, angles on a straight line. So U will be 180 minus 104. 10 minus 4 is 6, 76 degrees. So U is 76 degrees, and because of that, W, because if you look at this is X, okay? So W is U. U is equal to W, which is 76 degrees. Reason, vertical angles. The best thing is to just pause this video and do this yourself, and then you play it back to see whether we get the same thing. Okay, then we have here, we found our U. Now we look at this angle, there's a triangle here, and that is the way we can find our R. There's a triangle here. There's a triangle here in between. It looks like this because we have to do a triangle theorem here in order to find R. So if you look at this triangle here, this is J. There is J here. There is P here. P. Right? Angle P there. And this is R. R. So we know our J. Okay, our J is 22. And we know our P. Of course, our J is 22 degrees. Now, what did we get as our P again? I forgot it. F is equal to P. Okay, 85 is equal to F, alternate angles, and F is equal to P, corresponding angles. So our P is 85 degrees. Our P is 85 degrees. So how do we get our R? We can get our R right away. Because 22 plus 85 plus R should give us 180 degrees. Now, but what's the reason here? Reason, sum of angles of a triangle. Sum of angles of a triangle is equal to 180 degrees. Okay, so this means that R plus 2 plus 5 is 7, 2 plus 8 is 10, is 180 degrees. So R will be 180 minus 107, which is 10 minus 7 is what? 3? 73 degrees. R is 73 degrees. And from there, you can find S. You can now find S. So S will be what? S will be 104 minus 73. And this is 1. 10 minus 3 is 1. 31 degrees. S is 31 degrees. So we found all the angles here. Now S is correct. S is vertical to V. V is equal to S. V is equal to S, which is 31 degrees. Reason, vertical angles. Okay? V and S, W and this and U, then R and beta. Right? So, everything here should give you everything here. 180. So, we see that 31 plus W is 76. 76 plus 31 is 107. And of course, beta is R, which is 73. And 180, which gives you 180 degrees. So, R is equal to beta, which is 73 degrees. And these are vertical angles also, vertical angles. So let's go ahead and find the X, okay? So we have this. We have this to be our X. Then our K was what? 73 degrees, right? And then our S was what? 31 degrees. We got our S as 31 degrees, right? And then our K was 73 degrees. Okay? So now we see that 73 plus 31 plus X is 180 degrees. Reason, sum of angles of a triangle. So this will give you what? 104. 104 plus X is 180. So X is 180 minus 104. 10 minus 4 is 6. 76. Our X is 76. So our Z, our X is equal to Z, which is 76 degrees. Reason, vertical angles. And then our X plus Y is equal to 180 degrees. X plus Y is equal to 180 degrees. Reason, angles on a straight line. Angles on a straight line. So Y will be 180 minus 76, which is 104. So Y is 104. And then Y is equal to alpha, which is 104 degrees. Reason, vertical angles. Okay? Yeah, we finished that. I mean, it will take patience. Patience, you see, doing the triangles, patience. Okay, let's do number 2 and then we can call it a night. Now with number 2, we see that FH is parallel to GS and is parallel to KM. Okay, and then we see that FG is parallel to HK. FG is parallel to HK. So what we might want to do is to kind of do this and extend it. Okay, let's do something and extend it. H, F. Let's kind of extend it and see how we will get it done. H and K is here, then M, and let's extend this. Okay, and this is K. K is 80 degrees, and then this is S, is G. You can extend that. G is what we want to find. We want to find G, then we want to find F, and we want to find H. Okay, so but we see that this is parallel. This is parallel to this, and it's parallel to this also. Then this is parallel to this. You see, this is another way you can write parallel. That line segment FG is parallel to line segment HK. And the line segment HF is parallel to line segment SG and is parallel to line segment MK. So we can see here that this H is 80 degrees. Reason, these are interior angles. H is 80 degrees, alternate interior angles. Okay? And because of, and then H is equal to this angle here. This angle here is equal to 80 degrees. Because this is corresponding. This is corresponding to this. Okay? So because of that, here will be what? 180 minus 80, 100 degrees. Angles on a straight line. Okay? So you might call this B. Say that B is equal to 80 degrees and say that let's call it small h, okay? Small h is 80 degrees. Small h is equal to small b, which is 80 degrees. Corresponding angles. And then small f is equal to small f plus 80 degrees is equal to 180 degrees. Reason, angles on a straight line. So because of that, F is 180 minus 80 and F is 100 degrees. So this is 100 degrees. And then the same thing applies here anyway. Okay? The same thing applies here. This is 100 degrees. You can call this small A. A is 100 degrees. To F, A is equal to F, which is equal to 100 degrees. Reason, corresponding angles, and then small g is also 80 degrees. Okay? Small g is what? 80 degrees. Small g is 80 degrees. Because small g plus 100 is 180 degrees. Reason, angles on a straight line. So small g is 80 degrees. 180 minus 100, which is 80 degrees. Now another way you can look at this is this is 100 degrees, and because this is 100 again, 100 degrees, and if that is 100, this will be 80. Okay, that's another way you can look at it. And because this is 100, This one will be 100 also. And this will be 80. And of course this will be 80. And this will be 100. Okay? And this is 100, 100, 80, 80. Alright? That's another way you can look at it anyway. Okay? Alright, students, thank you so much for listening. And you have a good evening. Now, I'll post this video on my website, samuelchukwuemeka.com. Thank you so much for listening, and you have a good evening.